Welcome back to my Calculus Conundrums and Applications of Derivatives by the Perfect Square. Feel free to subscribe. And this one is going to continue applying the increasing-decreasing test to find where a function is increasing or decreasing. Now I'm going to start with a trig function, sine squared x plus sine x. Now the problem with trig functions is, trig functions generally just continue on and on and on and keep repeating certain iterations. So with trig functions, I'm usually just going to look at it over a specific interval. So for this function, I'm just going to investigate where it's increasing or decreasing on the interval 0 to 2 pi. So first of all, find the derivative. So apply the power rule to sine squared x and then apply the trig rule to sine x, and you'll get 2 sine x cosine x plus cosine x. And you can actually factor the cosine x out, and you'll get cosine x times 2 sine x plus 1 equals 0. And then solve for where cosine x equals 0. But remember, we're only staying within the interval 0 to 2 pi. So cosine x would be 0 at pi over 2 and 3 pi over 2. And then sine x would have to solve this, to set this equal to 0 and solve it, you would actually get sine x equals negative 1/2. And then that would tell us that x would have to equal 7 pi over 6 or 11 pi over 6. So first of all, when I draw my number line down here, make sure you realize that when I draw this number line, I'm only drawing it from 0 to 2 pi. So right here is 0. Can't get it to click for me. There we go. Alright, so right here we get 0, and then over on this end we get 2 pi. Okay, so now I won't label each of these, but I had to figure out what order they're in. So I figured out pi over 2 is the smallest of those four values, so that's pi over 2. Then the next is 7 pi over 6, so 7 pi over 6 is there. Then 3 pi over 2 would be there, and then 11 pi over 6 would be there. Okay, so if you look from 0 to pi over 2, now I just chose to use integers that I found between 0 and pi over 2. So I found that 1 was an integer in that range. So then I just plugged 1 into the derivative. Now you can grab a calculator and do this, but just plug 1 into this derivative, 2 sine x cosine x plus cosine x, and make sure it's in radians so it'll calculate it right. So when I plugged 1 radian in, the derivative turned out to be positive, so I know the function's increasing over that interval. And that would be, I'll try to draw it here, that would be this portion right here. Okay, and then pi over 2 to 7 pi over 6, 2 is within that interval, so when I plugged 2 in to the derivative, I found that the derivative is negative from pi over 2 to 7 pi over 6, and so that would be this piece right here. Forgive me for deviating off the graph there, but you can see it's decreasing there. And then from 7 pi over 6 to 3 pi over 2, I used the number 4. So when I plugged 4 into the derivative, I got a positive value, and so that means since the derivative is positive, that means the function is increasing. So that's this little piece right here, just right here. You see that little piece that's increasing there. All right, and then when I plugged a number between 3 pi over 2 and 11 pi over 6, I found that pi falls in that range, so I went ahead and plugged 5 into the derivative, and I got a negative number, so that told me that the function was decreasing over that interval, so that would just be right there. Well, I missed it, didn't I? It's right in there, so it's just from here to here, and the function is increasing. So anyway, all right, so now, and then the last interval, 11 pi over 6 to 2 pi, I found that 6 was in there, so I went ahead and plugged 6 radians into the function, and I found that the derivative, when I plug 6 in, is actually positive, so it's going to be increasing. And that's that little piece right here. And remember, it stops right there because you know, right there is where 2 pi. Down here I tried to label it for you so you can see this. This is 2 pi. This point right here is 11 pi over 6. This point is 3 pi over 2. This point 7 pi over 6. And then this point is pi over 2. And then of course it starts at 0. Alright, so that's how you determine with a trig function. And again, I want to make sure I say this. If you're taking a business calculus class, you probably can skip that example because anything that involves trig functions is usually not covered in business calculus. Okay, here's another function here. Notice here I have y equals the square root of 4 minus x squared. Now, write that as 4 minus x squared all to the 1/2 power, and then take the derivative of it and simplify it. And again, I'm letting you do the derivative. So when you do that, when you find that derivative, you're going to get minus x over the square root of 4 minus x squared. Well, this derivative would be 0 when x is 0. So 0 is a critical number. But it would also be undefined when x is -2 or 2. Now notice that -2 or 2 is in the domain, because you can't, if you plug -2 or 2 in here, you get the square root of 0, which is certainly a valid number. So that's in the domain. Now on these, for some reason I did the table a little differently on here. I just didn't show you all the little cells like I did on the others. But let me just real quickly show you here. You know, you've got the number line there, and so basically you've got let's see here. Okay, so the domain is -2 to 2. So I should have mentioned that earlier. It goes -2 to 2, and there's only one critical number that falls between -2 and 2, and that's 0. So I wanted to pick a number between -2 and 0, so I chose -1. And so when I plug -1 into this derivative, I got a -1 on top and a positive number in the radical. So that would be a negative divided by positive is negative. So I'm sorry, a negative divided by positive is, okay, let's start over. I completely messed that up. I got a minus -1, so I get a positive in the numerator divided by a positive. So a positive divided by positive is positive. So the function is increasing on that interval. And then when I plug 1 in, I'll get a negative divided by positive, which is going to be negative. So the function is decreasing on that interval. And you can see the graph if you want to, but I can show you kind of a rough sketch here without having to go to the graph. So if you were to graph this, you would basically get a semicircle like this picture here, and then you would notice that x equals 0. You'll see that from -2 to 0 the function will be increasing, and then from 0 to +2 the function will be decreasing. So that corresponds with what I stated there. I'm not going to work this one. I worked a couple just like this one on the previous one. So go ahead and pause the video here and work this one yourself. But I got two critical numbers, 0 and 4. And then so I just took my number line here and I broke it up right here at 0. I broke the number line up there at 0. And then here I broke it up at 4. And then I picked the test points within each interval and plugged them into the derivative. So you can do that one on your own. Okay, the next one, f of x equals x times the square root of x plus 1. You need to write x plus 1 as x plus 1 to the 1/2 power and then apply the product rule. So when I did, I got 3x plus 2 over 2 times the square root of x plus 1. Now since x plus 1 has to be greater than or equal to 0, then we know the domain of this function has to be from -1 to infinity. So keep that in mind. And then if you set the derivative equal to 0, you get -2/3 for a critical number. And then if you figure out what makes the denominator equal 0, you get -1 for a critical number. So those are the two critical numbers. So remember, it starts at -1 and then it breaks at -2/3. So my first interval is -1 to -2/3. And so I went ahead and just plugged -0.9 in for that. And when I plugged -0.9 in to this derivative, I actually got a negative number. So you can do that on your own. and so the function must be decreasing there. And then when I plugged 0 in, for I needed a number in this interval, so I plugged 0 in, and that gave me a positive number for the derivative, so the function's increasing there. So this is just a rough sketch of the graph. So the graph kind of starts at -1 here and then comes down and then turns upward. So if you look from -1 to -2/3, you'll see the function is decreasing, as I said there, and then from -2/3 to infinity, the function is actually increasing on that interval. Okay, let's take a look at two more real quick. I'm going to have to speed up a little bit here. Alright, so x over x squared plus 1, the derivative is minus x minus 1 times x plus 1 over x squared plus 1 quantity squared using the quotient rule. And so I get the critical numbers 1 and -1. So that's what I got when I set the derivative equal to 0. The denominator cannot equal 0 because x squared plus 1 can't be 0. So the only critical numbers you're going to get is 1 and -1. So I broke the number line up at -1 and 1. So let me kind of draw that for you. So I get -1 right here, and then 1 right here, and then so I kind of broke it there. Alright, and then I picked a number in here, -2, plugged it into the derivative, and I got negative, so the function is decreasing there. I plugged a number, I found 0 in this interval, plugged it into the derivative, got a positive number, so the function is increasing for that interval. And then I plugged 2 in from this interval and found that the derivative was negative, and so that means the function is decreasing. And again, you can plug these in yourself and find out whether the derivative is negative or positive. Here's a picture of the graph, and you can see here that the function is decreasing from -infinity to -1, then it's increasing from -1 to +1, and then it's decreasing again from 1 to infinity. And that's what I got on my answer. Okay, this is the last one. And on this one I have f of x equals cosine x plus sine x, and I'm looking at this on the interval from 0 to 2 pi. And so I'm going to find the derivative of this. I got minus sine x plus cosine x. You're going to set the derivative equal to 0, and then when you set it equal to 0, it gives you this equation, cosine x equals sine x. And then if you divide both sides of this by cosine x, you'll get 1. You'll get 1 equals sine x over cosine x, which is, since sine x over cosine x is tangent x, we know tangent x is 1. Now, you only need to worry about what's happening from 0 to 2 pi. So find out where tangent x equals 1 on 0 to 2 pi. And again, this is a trig problem, so if you're in business calculus, you can skip over this. But the tangent is 1 when x is pi over 4, and tangent is 1 when x is 5 pi over 4. So those are the two critical numbers. Okay, so my lines are a little crooked here, but basically remember the number line goes from 0 to 2 pi, and that's where it stops because that's the domain we were using. And this line right here breaks the graph at pi over 4, and then this line right here breaks the graph at 5 pi over 4. So I needed to look at the interval 0 to pi over 4, pi over 4 to 5 pi over 4, and 5 pi over 4 to 2 pi. So from 0 to pi over 4, I tried pi over 8. Now remember, I had to plug it back into this derivative. So when I evaluated minus sine of pi over 8 plus cosine of pi over 8, I actually got a positive number for the derivative. So that tells me the function is increasing. And then for pi over 4 to 5 pi over 4, I used pi. And so when I evaluated the derivative at pi, I got minus sine of pi plus cosine pi. I got a negative number, so that means the function is decreasing on that interval. And then for this interval, I used 3 pi over 2, and when I plugged that into the derivative, I got a positive number, so the function is increasing on that interval. So the function is decreasing on the interval pi over 4 to 5 pi over 4, and then it's increasing on the other two intervals. And I'll just show you a quick picture of it, because I'm about to run out of time on this video. Here's a picture of the graph from x equals 0 to x equals 2 pi. And notice that if you go from 0 to pi over 4, the function is increasing. You go from pi over 4 to 5 pi over 4, it's decreasing. And then from 5 pi over 4 to 2 pi, the function is increasing again. And got it just in the nick of time. Bye-bye.